Hi guys, today's experiment is recrystallization. Before we begin, please go ahead and read the textbook, the page number 678 to 699, the technique 11. So once you read this textbook, it will basically explain pretty much everything you need to know. The reason I'm making this lecture video is to help your understanding. Basically, I'm just summarizing that textbook. Okay. So after reading the textbook, please go ahead, try to understand the basic concept of recrystallization. And in order to understand the recrystallization, you need to review the polarity concept from the previous lab, which is solubility and solution. Okay, so by understanding the polarity concept, it will greatly help you to understand this recrystallization concept as well. Okay, so make sure to read the book and try to understand. Then come back to this lecture video and watch the rest of it. So basically the recrystallization is a very common and conventional organic chemistry technique. I mean, just purification technique for solid compounds. So in organic chemistry, we always have like solid compounds, liquid compounds, those two physical state molecules. But recrystallization is only applicable for solid compounds. And then the solubility of the compound in a specific solvent is the most important property that we need to know to perform recrystallization. So let's talk about the basic principle of recrystallization here. So let's say we have impure solid compound and we need to purify it. Of course, there are many different ways to purify this compound. However, we're going to use the recrystallization in this lab. So the first thing we have to do is to find out the solubility of this compound in a specific solvent. I'm going to talk about it soon. Then once we find that suitable recrystallization solvent, then we're going to dissolve this compound at elevated temperature. So basically we're going to try to dissolve this compound in boiling solvent. Then once these impure compounds are dissolved in the solvent, then in the boiling condition we obtain this homogeneous solution. And that's pretty much done. After making this homogeneous solution at elevated temperature, then all we have to do is just to cool down the solution to the room temperature. And slowly, once the temperature drops to the the room temperature, then eventually we will obtain the initial solid compound back. But in this process, in this recrystallization process, what happens is all the impurities are left behind the solution. So basically, let's say in a container, we have our compound. Let's say it's a homogeneous solution. But we also have these impurities inside this, dissolved in this homogeneous solution after dissolving it. But when they cool down, what happens is only these pure molecules, they have tendency to just combine each other and crystallize. And these impurities, the circles here, the circles are impurities. These guys cannot just combine to these pure the target our product molecule, and at the end in the container in the solution we have these crystals, the solidified compound, and then in the solution these impurities are just floating around. They're just pushed away by this compound. It is very interesting behavior of the compounds when they are cooled down to the room temperature from the homogeneous solution. So we're using this type of property of organic compounds. Okay, so then after getting these solidified pure compounds, all we have to do is just collect them through the vacuum filtration. That is it. So now I mentioned about the solvent. Well, the choice of the solvent is very critical factor in this recrystallization experiment. So we need to find a good recrystallization solvent for that specific compound. So there's two conditions. First, the compound should be sparingly soluble at room temperature. Okay, so basically what it means is that it should be almost insoluble at room temperature in this solvent. And then at the same time, once we increase the temperature, once we apply heating to that solution, then that compound should be highly soluble at elevated temperature. Most likely, we always heat up the solution to the boiling point of the solvent. So if you read the textbook already, you probably have seen this graph. So let's take a look at one by one. So x-axis is the temperature, and then the y-axis is the gram soluble, which means the solubility of the compound depending on the temperature. So if we take a look at the solvent A, which is a good solvent for the recrystallization, it is very soluble at elevated temperature here, okay, but at the room temperature, let's say this is 25 degrees, the room temperature, then its solubility is very poor. So that is the behavior of the solvent that we always have to look for recrystallization. Okay, that is a good solvent you have to choose. But for the solvent B, initially at the room temperature, the solubility is very poor, but although we increase the temperature of the solution, then the solubility doesn't improve at all. So most of the time, let's say this is about 100 degrees, which is the boiling point of that solvent, but still the solid doesn't dissolve, and we cannot recrystallize it. We cannot dissolve the compounds, therefore we cannot use this solvent. And then the last one, the solvent C, is very soluble even at the room temperature, and then at the elevated temperature, but still has a really good solubility. So what that means is that although we cool down this one, this solution to the room temperature, but still, because it has just a good solubility at the room temperature for the compound, then the compound is not going to crystallize at all. Okay, so that's where we need to always consider a good recrystallization solvent should have this behavior. Okay, low solubility or almost no solubility at the room temperature, but has a really good solubility at the elevated temperature. Okay. Then another concept you need to consider for the recrystallization is that we've been talking about the recrystallization, but there's another term for the organic compounds like a to solidify the organic compounds. Another term you probably have heard before is called precipitation. So now you need to consider the difference between these two. Recrystallization is a very slow process. In the previous slide, we talked about, okay, we heat up the solution to dissolve the compound in a solvent, then we just slowly cool down. So we're just basically providing enough time for the compound, for the molecules to solidify in the solution. However, precipitation is a rapid process. So what it means is, let's say in this homogeneous solution, let's say we have our compound, which is a star here, but these impurities, the circles, so are also present in the solution after dissolving the impure compound. But then if you cool down this solution rapidly, then what happens is that these impurities will be trapped inside the crystal lattice of the pure compound. And again, we won't be able to obtain pure solid if precipitation occurs. Okay, so these are the two terminologies that you need to understand the difference between these two. And I believe this will be on the final exam at the end of the semester. All right, so this is the basic concept of recrystallization. Then in this experiment, we'll be very specific. Well, first of all, you don't need to find out the best or the suitable solvent to purify our impure sample, which is acetanilide. The choice of the solvent is already given. We're going to use water as our recrystallization solvent. So starting with the impure acetanilide, we're going to use water as a solvent. We're going to perform the recrystallization. So please go ahead, watch the video, for the whole process. And at the end of the video, it also shows the mass recovery that you need to record in your notebook and for your lab report. So we're going to find out the percent yield. I'm pretty sure you guys know how to calculate the percent yield. Okay, if you don't know, it's okay. Just throw the question in the discussion board. Okay, but you better know how to do it because you'll be doing it for the entire semester. Not only this semester, but also the next semester, which is the second semester of OChem lab. Okay. And then after recovering the purified acetanilide, we're going to determine the purity of the compound. Unfortunately, I cannot really coordinate the camera to our melting point apparatus. So in the video, the melting point of the crystallized acetanilide is provided almost at the end. So you should record that number, the melting point, for your report. Okay. So after determining the melting point of the purified acetanilide, then now you need to compare the purity of impure and pure acetanilide based on the experimental melting points provided in the video. So that's pretty much it. We try to purify acetanilide, which contains about 10 or 20% of the impurity. I'm not going to tell you what the impurity is, but after recrystallization, we should have pure acetanilide. Okay. So that's pretty much it for this experiment. It's a very simple but sometimes it could be really powerful, a powerful technique for organic chemistry labs. Okay, I hope you enjoyed the experiment video, and if you have any questions, let me know. All right, that's it.